Okay. So in the previous classes, we studied about we started with the modules and the ports, how it has to be designed. But these things we studied in the earlier itself. But this is a part of this module as a theory question we need to write. Then here the one thing is we showed nearly the port declarations is already we studied in Verilog. We are having totally three ports are there, that is input, output as well as in-out actually. Still we are not used in-out. The in-out port will be used for a bidirectional port. Sometimes the same port can be act as input as well as output. So that kind where we'll use in out in the sense you can take an example as a latch, SR latch you can think. Example I'm saying the SR latch normally what will happen the Q and the Q bar will be connected to S and R the input, the output will be connected to input. So at that point of the time it may be declared as a in out, even you can declare as a output also fine actually. It will work, it will consider as in out. So here there is a one more type, the module syntax in the Verilog is there, that is called as ANSI C style. So what is the ANSI C style port declaration? This is what we explained in the previous class. You consider this is the normal Verilog model which you wrote still now, the 4-bit adder actually, like a module, then input, output, register like this. We written the program. Now ancestry style in the sense we can reduce these many lines into like this in the sense. So like a module full adder, see here instead of declaring inputs, outputs, registers separately here, we have to declare within this bracket itself, within the module itself we can declare. See output reg 3:0 sum, output reg c underscore out. So no need of to declare once again separately input and output as well as register. So by default this input, both the input will be considered as wire normally, so output will be register. So this is the style called as ancestry style. So in our lab, in our HDL lab, we are going to use this style only. We'll use by default we'll get this style only. So don't get confusion. In our software we'll get like this only. Now we need to know something like a port connection rules. Actually, when you're going to connect a port, how it will be connected. Like example, normally what will happen when you are connecting like see example you take this. This is nothing but a port connection rule here on box is there. See this is externally you are connecting net. Normally net is the wire. You assume that only, right? This is a wire actually. You consider the here inbuilt we are having some kind of circuit is there inside the box, some circuit is there you think. So now you see outside this is a box here register or net, here net. We can see here one thing I'll say, we are having how many ports in Verilog is available, totally 3 actually. So what are those? The one is nothing but I can say input, output, then in out, right? So input, output, then in out. So the 3 is there.